Okay, so the first one, I guess I'm just going to kind of put it together. Oops, I guess I need a pencil. The 3's can go away, right? And then I get the square root of 5u cubed v over 2u cubed v cubed. So the u's go away, and 1v goes away. So I get, let's see, what do I get? The square root of 5u over the square root of 2v squared. Okay, sorry, that should be squared. So that gives me the square root of 5u over the square root of 2. And then I'm going to multiply by the square root of 2 over the square root of 2. So the square root of 5 STUV, UV 2V. Eesh, that was ugly.
Good job.
Thanks, Nia. So I get 4 times the square root of 6b cubed over 15b squared. So those b's go away, and I get left with 1 on top. What goes into 6 and 15? 3? Yeah, so that would be 3 goes into 6 2 times, 3 goes into 15 5 times. So I'm going to get left with 4 square root of 2b divided by square root of 5. So multiply by square root of 5 over square root of 5. So that should give me 4 square root of 10b divided by 5. Okay. And then, okay, so let's see, the fourth root, 4 times the fourth root of 10n squared over 135. So I'm assuming 5 goes into both of them. That's probably a good assumption, right? 4 fourth root of, I don't know why I didn't simplify it up here. 5 goes into 10 2 times. 5 goes into 135. I don't know how many times. 135 divided by 5 is 27. Beautiful. 27 times. So then I get the fourth root of 2n squared divided by the fourth root of 27. And 27 is 3 to the third power, so I need to multiply by this. The fourth root of 3 divided by the fourth root of 3, or times the fourth root of 3, sorry. So that's going to equal 4 the fourth root of 6n squared divided by 3. That's really ugly. But that's what it is.
Wait, so then why did you put it with the 3? I don't know why.
27 times 3 is 81, and the fourth root of 81 is 3.
Got it.
Because, right, 9 times 9 is 81, and that's 3 times 3, and 3 times 3, 4 3s. Yeah. Let's see. Well, I can't simplify this one. Okay, but let's see. 125 is 5 to the third power. So I'll need another 5 under there and another x under there. So the fourth root of 5x over the fourth root of 5x should equal 4x, fourth root of 5x all over 5x. So the x's go away. Should be 4 fourth root of 5x over 5. Yeesh. Yeesh. Okay, there we go. Questions? Rachel's already been in here. Beautiful. Okay, so now we're going to move from multiplying and dividing to a little bit harder, adding and subtracting. It's not really too much harder, but the things with the deal with adding square roots is they're kind of like variables. They have to be the same, or else I can't add them together. So I think of roots as being like needing to have to be a like term. So if it's not the same root and the same root, so the square root, cubed root, fourth root, that has to be the same. And also what's underneath the root has to be the same. So it all has to be the same. So if you look at this one, this is a fifth root, the square root of 5 and the square root of 5 is the same. So that's like them both being an x. So I can combine those together. So that means that this 6 square root of 5 plus 2 square root of 5 would be 8 square root of 5. But I can only do that because these two things that I highlighted are exactly the same. Does that make sense, you guys? Does anybody have any questions about that? Okay, so if we go to the next one, notice my like terms here would be the square root of 7 and the square root of 7. And then I've got the fifth root of 2 and the fifth root of 2. So I have two different like terms. So if you kind of think of that as a like term, those are two different, like an x and a y, right? So I've got 5 square root of 7 plus 1 square root of 7 would be 6 square root of 7. And negative 8 fifth root of 2 plus 9 fifth root of 2 would be 1 fifth root of 2. That's it.
Yes.
Yeah. Okay, so now as long as the roots are the same, it's fairly easy. Now let's look at number 3, where my roots are not the same. Now I need to make them the same, or try to make them the same. So if I look at 50, I know that 50 is 25 times 2. Is everyone okay with that? That's 25 times 2. So that means I can write this as 9 times the square root of 25 is 5, and then I get root 2 minus 4 root 2, which is going to equal 45 root 2 minus 4 root 2, or 41 root 2. Is that one okay? Is everyone okay with how I got 45? Let me make it bigger. Is everyone okay with how I got 45? Is there any questions on that? Okay. Okay. Yeah, so I took 50, the square root of 50, and that's 25 times 2. And the square root of 25 is 5. But this is 9 times the square root of 50, which means it's going to be 9 times 5, which is 45. Okay. So I'm going to do the same thing on this one. This one just has both the 12 and 27. I'm going to try and simplify this time. And 12 is going to be 4 times 3. And 27 is going to be 9 times 3. So I have 5 times the square root of 4, which is 2 square root of 3, plus 16 times the square root of 9, which is 3 square root of 3. Whew. Okay, 5 times 2 is easy. That's a 10 square root of 3, plus, I believe it's 48 square root of 3. So that should equal 58 square root of 3. Okay? Not too bad? Great. I'm going to have you guys try the next 6 problems. Sorry, I made it fit on my iPad and not the computer screen. Stop. Okay. It's frustrating for a teacher to have no one talk to you. So let's go ahead and do this. So for A, I think everyone who put it in the chat box, it looks like everyone got at least the first 3 right. So 4 plus 7 is 11 square root of 3. And then B again, it has a common denominator, or like terms, common denominator, like terms. So this was a 2 cubed root of 4. And then C also had like terms. So 8 minus 1 is 7, plus 5 is 12 square root of 2. And then once we get down to D, E, and F, we don't have like terms anymore. We have to get like terms. So 27 is 3 times 9. I don't know why I didn't write it that way. So square root of 9 is, so that's 4 times 3 square root of 3 minus 3 square root of 3, or 12 square root of 3 minus 3 square root of 3. 12 minus 3 is not 9. 9 square root of 3. Beautiful. And then the cubed root is a little bit harder. So this is 8 times 2, and this is 27 times 2. Well, the cubed root of 8 is 2, and then I have the cubed root of 2, plus the cubed root of 27 is 3, and then I have the cubed root of 2. So 6 plus 3 is 9, cubed root of 2. Questions?
No.
Okay. You guys online okay? Awesome. Same thing here, right? It's still a cubed root again. So I have the cubed root of 27 is 3 minus 5 times the cubed root of 8 is 2. So 3 minus 10 equals negative 7. Wow. Okay. Is there any questions? Are you okay with that?
Yeah, I just couldn't do it.
Okay. So if we go on to the next one, now we're going to start multiplying square roots with foiling or the box method, or however you want to multiply it. So, so we're going to go ahead and distribute this. So I get 5 square root of 3 plus the square root of 6. And there's nothing to simplify, so I'm just done with that one. That one was simple. This one's a little harder, or a little more involved, I guess I should say. So I'm going to distribute this again. And I get the cubed root of 8 minus 2 times the cubed root of 64. Is that right? 64? 64. So, and then the cubed root of 8 is 2, and the cubed root of 64 is 4. So 2 minus 8 equals negative 6. Hey, Tua, do you know what time class starts? Tua?
No, I don't.
Really? You really don't? 10:56, Tua.
Oh,
The Zoom says 11, I believe.
it says 11:30.
See, told you.
Does it say 11:30?
It says 11:30. That's why I've been coming in 11.
Oh, sorry. But the class says 10:56 in Canvas.
Yeah,
Yeah.
I've seen that.
The Zoom I can't change to like others than half an hour, so sorry. I didn't know actually it said 11:30, so sorry about that. 10:56, Tua. That's okay. Maybe I won't have to tell you more than once like I've had to tell somebody in this class that's here right now. That's laughing and making fun of you.
Okay.
Notice she got really quiet really quickly.
Wait, is this so? Yeah. Since I have my camera on, is it extra credit?
As long as you leave it on all period, yes. Every day you leave it on all period, you get extra credit.
You see the Delta math I got done, huh?
I haven't actually done you guys' grades yet today. I'm going to do them tonight.
It's gonna surprise you. What?
I won't say anything until I see it. Okay, so here we go. Again, oh, here's McKenna. I think she was already in. She must have got kicked out. So I'm going to distribute this 4 times 2 and 4 times the square root of 5. So 4 times 8 plus 4 square root of 5. And then negative 5 times 2 is negative 2 square root of 5 minus the square root of 25. Woo! So that's 8 plus 2 square root of 5 minus 5. 3 plus 2 square root of 5. Done. Questions? Not too bad, right? Tua, you have any questions? Awesome. So we're going to do the same thing for number 4. You can also multiply these out using the little box method if you want, right? Whoever, I want to do them both ways so you guys can decide which way you like the best. It doesn't really bother me either way you want to do it. So I've got the square root of 12 plus the square root of 5 and the square root of 12 minus the square root of 5. And then this is the square root of 144 or 12, right? And this would be the square root of 60. And this is negative square root of 60. And this is negative square root of 25 or minus 5. So that means this whole thing multiplies to be 7. Done. Okay? Because this right here, my like terms equals 0, and then 12 minus 5 is 7. Any questions? Right. Okay, and I can do the same thing on the square, right? What does it mean to be squared? It means to multiply by itself, yes? So if I make my multiplication table here, I've got 3 square root of 10 and 3 square root of 10, which is going to be 9, and then 3 square root 10, 3 square root 10, and then the square root of 100, which is 10. Okay, so that gives me my like terms. 9 plus 10 is 90. And 3 square root of 10 plus 3 square root of 10 is 6 square root of 10. So there's my, I don't know why I said 90. That's not 90. Wow, thank you. It is 19. 19 plus 6 square root of 10. Beautiful. So much better when I can add instead of multiply. Yes. Okay. And then one more, just with 2 square roots. So I'm going to do the box again because I like the box. You guys don't have to do it. You can do the foil, whichever way you want to do it. So I've got the square root of 3 minus the square root of 2, square root of 3 minus the square root of 2. And that's going to give me the square root of 9, or 3 minus the square root of 6 minus the square root of 6. Square root of 4, or 2. So that's going to give me 5 minus 2 square root of 6. Okay, any questions? Not too bad on multiplication either? Okay, so let's have you guys do, there's 6 problems here. And is, what is A? A is 3 square root of 30 minus 3 square root of 35. And B is 3 minus 4 root 3 of 63. C is 4 plus 3 root 6. D is really long and ugly, and it's negative 7. Whew.
Not the ugly.
It is plus, and whichever order you wrote these in, root 6 plus root 21 minus root 14, whatever order you wrote those in, that's the answer. So it could have been, the negative 7 has to be first, right? The whole number needs to be first. So it could have been plus root 21 plus root 6 minus root 14, or minus root 14 plus root 6 plus, right? It doesn't matter what order add and subtract in. So as long as it's those 4 pieces are in your answer, you're great. Okay. E is, where's E? 23 plus 8 root 7. And then F is 2t plus 5 plus 2 root 10t. Any questions on any of those?
You didn't have to simplify them?
You can't simplify that one.
Or like all of them?
I've simplified everything that I can.
Wait.
What did I do then?
On which one?
All of you?
Yeah, there's no roots that I can add together. There's nothing that can be simplified.
I'm just a little dummy, it's fine.
Are you okay?
Yes.
Remember, you can only add the roots together if they have the same root, right?
Yeah.
Okay. Were you adding them together and they weren't the same?
Yes.
Okay. Can't do that.
I even wrote a note and I was like, can't do that, and then I did it.
Okay.
Camel, do you have a bongo?
Okay.
No, like not a bongo instrument, like a bongo, like the thing that goes in the iPhones if you don't have like a
No.
cord.
A dongle?
Dongle.
Oh! It's a dongle.
Dongle. Yeah, no. No, I don't.
Wait, it's a dongle?
Yeah, D-O-N-G-L-E.
Oh, I need one.
I don't have one. Okay, so now we're going to rationalize the denominator. Notice I don't just have a square root in my denominator now. I actually have an expression in my denominator. I'm still going to multiply by 1, like I did yesterday when I rationalized the denominator, right? But now it has to be a special one. Yesterday was a special one too, right? It was whatever square root was in the denominator, or whatever root made the cube root or whatever, right? Made it equal whatever the cube root, whatever would take it out of the root, right? Well, this time I have to multiply by, oh my gosh, what I totally wrote down, I totally told myself to remember what it was called, and now it went out of my head. Oh, my Lanta. Oh, well, I know what it is. I still can't remember the name of it. But it's going to be the opposite. It's not the opposite. I'm going to take the denominator, and I'm going to do the opposite sign of the middle number. So I'm going to multiply by 4 plus the square root of 5 on my first one. Oh my gosh, there's a name for it, and it's just right there. I'll remember after you guys leave. You know that, right?
Yeah. I hate when that happens.
I told myself I'm going to remember what it was, and then I get to it, and it's just like right there on the tip of my tongue, and I can't remember what it is. So I'm still multiplying by 1, right? The same thing over the same thing is still 1. So I'm not changing the value of my fraction. I'm just changing the appearance of it. So there won't be a square root in the denominator because, that's a horrible thing to have. So that means I'm going to multiply the top and the bottom. Okay? So let's multiply the top first, because that'll be the easiest on this equation. So I've got, what is that? 20 plus 5 root 5, right? Okay. And now I'm going to come over here in my, my little area. God, I can't remember the name of anything today. My margin, that's the name of this area. Whew. And multiply the bottom. So, okay, I definitely need some sleep. And I'm going to multiply 4 minus the square root of 5 times 4 plus the square root of 5. And we're going to see what we get. So 4 times 4 is 16, and then I get 4 square root of 5 and minus 4 square root of 5. That's why I have to have 1 plus and 1 minus. What does that do to my two like terms there? Makes a 0, right? So it cancels it out. And then I get minus the square root of 25, which is minus 5. So because I have one plus up here and one minus here, it takes these two terms and makes a 0. The terms with the square roots, and it makes a 0. And then I've got 16 minus 5, which is 11. Done. Okay, so that's why I always want to multiply. Take just I don't need to change the sign of the first number, just the sign of the sign between the two numbers.
So you're trying to catch me.
Yeah. So I just need to take the sign between the numbers and change it, and that will make my two square roots cancel each other out and make a 0. So I don't have any square roots anymore. There is a name for it, and I just cannot remember what the heck it is right now. I know, you guys walk out. I'll be in the middle of next class, and I'll just say it, and they'll be like, what the heck? I'm like, I'm sorry. It's been bugging me since the middle of next class. Last class. So my juniors will be laughing at me, just so you guys know. Because we're going to be talking about probability and stats for ACT, and I'll just blurt out what this name is, and they'll be like, what? So this one I'm going to multiply by 5, the square root of 5 minus the square root of 2, divided by the square root of 5 minus the square root of 2, right? I'm multiplying by 1. So I'm doing this. This one's a little harder because, I have to do the top and the bottom. Well, I had to do the top and the bottom on the last one, but I only had one term in the top. This one's a little harder. So I can do the, I gave myself plenty of room. So I'll just do my little, you can do the FOIL or the box method. I don't care. I like the box method just because it's a little organization. Square root of 5, and then we've got the square root of 5 minus the square root of 2, and then we have the second. I'm just going to go ahead and set both of them up right now so I can just do the multiplication really quick and easy. So I've got the square root of 5 plus the square root of 2, and the square root of 5 minus the square root of 2. Okay, so let's multiply them. This is the square root of 35 minus the square root of 14, square root of 25, which is 5, and minus the square root of 10. Yeah, that's right. Okay, so this is the square root of 25, which is 5, minus square root of 10, plus square root of 10, minus square root of 4, which is negative 2. So in my numerator, we're going to get 5 plus the square root of 35 minus the square root of 14 minus the square root of 10. So lovely. Over 5 minus 2 is 3. Done. Okay, guys, so somebody asked me to do these, so I'm going to multiply by 3 plus the square root of 2, divided 3 plus the square root of 2. So I'm going to distribute my 6 through on the top on A, so I get 18 plus 6 square root of 2, divided by, and then I'm just going to do this one out the other way because some people are doing the FOIL. So I'm going to do this bottom out FOIL wise. So I've got 3 minus the square root of 2 times 3 plus the square root of 2. And so 3 times 3 is 9, and 3 times the square root of 2 is 3 square root 2. And then I get minus 3 square root 2 and minus the square root of 4. So this is 9 minus 2, or 7. So it's all over 7. Done. Okay? And then for the second one, I'm going to multiply by square root of A minus the square root of B. So square root of A minus the square root of B. So I'm going to get, let's see, what do we get on top? A minus the square root of AB. Because the square root of A times the square root of A is A. And then the square root of A times B. Are we okay with that? So then the bottom, we're going to get, let's see, what are we going to get on the bottom? This one, we're going to do this way. Square root of A plus the square root of B Square root of a minus the square root of b. That's a really ugly a. Sorry about that. So this is the square root of a squared, or a, the square root of ab, minus the square root of ab, minus the square root of b squared, which is minus b. So all over a minus b. Okay? And then this one, this lovely one, I'm going to multiply by square root of 3 plus the square root of 7, square root of 3 plus the square root of 7. So I've got square root of 7 minus the square root of 3, square root of 3 plus the square root of 7. So that's the square root of 21 plus the square root of 49 minus the square root of 9 minus the square root of 21. So that's 9 minus 3. Not 9, sorry. 7 minus 3. So I've got 4 on the top. And then for the bottom, I've got the square root of 3 minus the square root of 7 times the square root of 3 plus the square root of 7. It's just going to change some signs a little bit. So I've got the square root of 9 plus the square root of 21 minus the square root of 21 minus the square root of 49. So this one's 3 minus 7, which gives me negative 4. So my answer is negative 1. Yeah, I saw, Eric. That's okay. Does that make sense?
Yeah.
Yep, that's it. Done.